Okay, wanted to give you some instructions regarding the OpenIntro Lab. And so the first thing you're going to need to do is you're going to need to download R and follow the instructions, depending on your computer, download the appropriate version of R. You must install R first. Once you have R downloaded and installed, then I highly recommend downloading RStudio and downloading, come over here and you will download RStudio and download and install the appropriate RStudio program for your computer as well. Okay, once you have that, then you can go ahead and open up the lab instructions, which appear here, and I will walk you through the first part of this lab in RStudio. Okay, so I've already installed R in RStudio, and so when I start up RStudio, it will look like this. Okay, and so let's just kind of read through this. And it says, the goal of this lab is to introduce you to R and RStudio, which you'll be using throughout the course, both to learn statistical concepts and whatnot. Okay, it says, to straighten out which is which, R is the name of the programming language itself, and RStudio is a convenient interface. It's kind of the program through which we interact with R. As the labs progress, you are encouraged to explore beyond what the labs dictate. A willingness to experiment will make you a much better programmer. That is true. Before we get to that stage, however, you will need some basic fluency in R. All right, so let's take a look. And it says the panel in the upper right is your workspace. Okay, and so this is my workspace. It says this is my environment, and it kind of lists off the things that are in my environment. And so it says environment is empty in the example here. Over here on the left, this is called the console. This is where you type in your code and R interacts with you. And then if we create any kind of stuff, it will appear generally down in this lower section here where it says plots or whatnot. Okay. It says every time you launch RStudio, we'll have the same text at the top telling you kind of the version of R that you're running. I think mine is one tiny bit outdated, 3.42. Yours is going to probably be a little bit newer than that, but that's okay. And this little caret here, this little thing is known as the prompt. This is where you would type in your commands. Okay, so initially it says interacting with R is all about typing commands and interpreting the output. These commands and their syntax have evolved over decades and now provide what many users feel is a fairly natural way to access data and organize, describe, and invoke statistical computations. Naturally is going to be relative depending on how familiar you are, okay? And so the first thing we want to do is to get some data into R, okay? And so what I will do is type in this command exactly as it appears on this web page here. So I'm going to just kind of shrink this down. And one thing I encourage is, you can copy and paste this, but I do think it's generally a good idea to just type things out yourself. And so anyway, I'm typing this out, www.openintro.org/stat/data/r-but-not.r. Okay, close quote and close parentheses, and I'm going to go ahead and hit enter. And when I hit enter, we can see something changes in my corner. It says data, and it says Arbuthnot 82 observations and of 3 variables. Okay, and what this does is it says this command instructs R to access the OpenIntro website and fetch some data. And you should see that the workspace area in the upper right hand corner now lists the data set called Arbuthnot that has 82 observations on 3 variables. And as you interact with R, you will create a series of objects. Sometimes you load them as we have done here. Sometimes you create them yourself as the byproduct of a computation or some analysis that you performed. And note that because you are accessing data from the web, this command will work in the computer lab, library, or dorm room, wherever you have access to the internet. Okay, so this is what we have. The data refers to Dr. John Arbuthnot, an 18th century physician, writer, and mathematician. He was interested in the ratio of newborn boys to newborn girls, so he gathered the baptism records for children born in London for every year from 1629 to 1710. And we can take a look at the data by typing the name of the data into the console. So here I would just type in Arbuthnot. Now, RStudio often will try to autocomplete, and I can just hit enter at this point in time. And if I hit enter, it lists off all 82 records and the 3 variables. And we can see the variables are year, boys, and girls. And we can see in the year 1629, there were 5,218 boy baptisms and 4,683 girl baptisms. Okay, and it says what you should see are 4 columns of numbers, each row representing a different year. The first entry is simply the row number. Actually, I didn't even mention that, but yes, it is the row number. And then the second is the year. The third and fourth are the number of boys and girls baptized that year, respectively. And use the scroll bar on the right to examine the complete data set, which you can do. Okay, so this is what we have. So the row numbers are not part of Arbuthnot's data. R adds them as part of its printout to help you kind of help you out. And this kind of table or spreadsheet is known as a data frame. And we can see the dimensions of this by typing in dim parentheses Arbuthnot. Okay, so I can type in dim Arbuthnot, and it will say 82.3, and this means I've got 82 rows, 3 columns. All right, and that's what we have. And here we have names Arbuthnot, and this will tell me the names of the columns or the names of the variables. So I can say names Arbuthnot, years, boys, and girls. So those are the 3 variables that I have to deal with. Okay, and it says you should see that the data frame contains the columns year, boys, and girls. At this point, you might notice that many of the commands in R look a lot like functions from math class. That is, invoking R commands means supplying a function with some number of arguments. So it's kind of like function parentheses and the argument that we're giving it. Okay, the dim and name commands, for example, each took a single argument, the name of data frame. So we say into this function dim, we provide it the name Arbuthnot, and it does its command, which tells you the dimensions of the data frame. Names takes in the data frame, and it tells you the names that are in the data frame. One nice thing about RStudio is that it comes with a built-in data viewer, and so you can actually click on the name Arbuthnot in the environments page, environment pane, and it will bring up something called the data viewer. All right, and so let's go ahead and try that out. And so if I go ahead and if I click this, it brings it up in the data viewer, and we have pretty much the exact same information that is printed here, but just in kind of this little data viewer window here. And I'm going to go ahead and click X to X that out. Okay, it says let's start to examine the data a little more closely. We can access the data in a single column using a command like Arbuthnot $boys, and this will only show the number of boys baptized each year. Okay, so let's go ahead and try that. And so it's going to just extract this column for boys. So I would just write Arbuthnot $boys. And this is just a column, and we can see exactly these values, right? The last number here is 7640. Second to last is 7840, 8239. So they match up. They match up accordingly. Okay, so what command would we use to extract just the counts of girls being baptized? Well, for that, we would do Arbuthnot $, and instead of boys, we would go down and we would select girls. Okay, Arbuthnot $girls, and we would do that, and that would be the command that we would run to extract. the girls being baptized. Okay, and it says, notice the way R has printed this data is different. When we looked at the total data frame, we saw 82 rows, 1 on each line, and these data, when we did it this way, are no longer structured in a table with other variables, so they are displayed one right after another. Objects that print out in this way are called vectors. They represent a set of numbers. R has added in brackets along the left side to indicate locations in the vector. For example, 5218 follows bracket 1, so what we have is bracket 1, 5218, indicating this is the first value in that vector, okay? And later on, in my example, instead I have bracket 16, and this is the 16th value in this vector. And this right here is the 31st value. So pretty much each of my rows have about 15 values. So this is the 76th, 77th, 78th, 79th, 80th, 81, 82. And we can see we have 82 values if we count them all out. And that's what these bracket 1, bracket, all of these things represent. For the shorter answers, the answers were also a vector of 82 and 3, and there are only 2 values, but it starts off with bracket 1 to indicate that the first value in that vector is 82. And here I had a vector with 3 values, and it had bracket 1 to indicate that the first value is year. But again, you know, it really only makes a huge difference when we have many values and all of these brackets appear. R has some powerful functions for making graphics, and we can create a simple plot of the number of girls baptized per year with the command plot. X is going to be Arbuthnot year, and Y will be Arbuthnot $girls. Okay, so let's go ahead and try out that command. So I'm just shrinking my window so that I can see the thing, and I'm going to type in plot, parentheses, X is equal to Arbuthnot $year, comma, Y is equal to Arbuthnot $girls. Okay, you want to make sure you type that in exactly as it is, and I do recommend typing it in over just copying and pasting. And then I hit enter, and we see a plot being produced, and I can click zoom here to make the plot bigger. And what do we see? This is the plot that has been created. We can kind of see the number of girls starting off in at the beginning where our data was being collected around 1629. So 1629, it seems like the trend goes up. There's a dip in the number of girls being baptized, and then it rises back up. Okay, let's see kind of what we have. It says, so by default, R creates a scatter plot with each XY pair indicated by an open circle, and the plot itself appears under the plots tab of the lower right corner. And notice that it says it looks like a function, this time 2 arguments separated by a comma, and the first argument in the plot function specifies the variable for the x-axis, which is the year, and the second, the variable for the y-axis, which will be the number of girls baptized. If we wanted to connect the data points with lines, we could add a third argument, the L, to say the type of graph we want to create is a line graph. So this is what we've produced. Again, the plot appears down here, and we can zoom into that. Because the next command is so similar to the previous command, on the keyboard, I'm going to just hit the up arrow key, and it brings in the last command that I typed in. I'm going to hit change this and type in the comma type equals quote L. And I do this, and now instead of circles, I now have a lines connecting each point in our plot. Okay, and how do we know what kind of things can we put into the argument for plot? We can do question mark plot for help Okay, so if you want help on any function, you can just type in question mark, which says I've got a question about this function plot, and I hit enter here. And here is the help viewer. And again, like many things, you can click kind of the pop out and it will list off all of the different things. And there's all these details, and a lot of times the help might be a little bit overwhelming at first, but sometimes you can just kind of go through and see what arguments they have, and they have different examples that can be helpful. All right, so here it says, notice that the help file replaces, okay, you can toggle between plots and help files using the tabs at the top of that panel, and that is true. So here, help came in here, and if I wanted to see my plot again, I can just click each of these things here. All right, is there an apparent trend in the number of girls baptized over the years? How would you describe it? I would say it seems to increase in the beginning. There is a sudden drop, and then the number of baptisms seems to go back and increase again. So there does seem overall there's a overall increasing trend with kind of an unusual drop here. And so perhaps we could look up some historical information about London in the 1650s and late 1640s and 1650s to see, was there something unusual that happened that caused the number of baptisms to drop during that time. Okay, it says, now suppose we want to plot the total number of baptisms. To compute this, we could use the fact that R is just a big calculator. So we can type in mathematical expressions like 5218 plus 4683, which if we looked at the top, this is kind of our first row, 5218 plus 4683. 5218 plus 4683, and it returns back 9901. Okay, and we can do that for the first year, and we could do this for every single year, but that would take way too long for us to have to do all 82. So R can actually combine, add this and this together element wise. So it'll add the first element with the first element here, the second element with the second element here, and so on and so forth. And instead of you typing in these individual numbers, we would just give it kind of the names of these vectors here. Okay, so we have Arbuthnot $boys plus Arbuthnot $girls. So that's exactly what we have here. So we're just going to type those two things, Arbuthnot $boys plus Arbuthnot $girls. Now, you don't have to put spaces in between the plus. You can. It doesn't matter. Okay, so if I do that, then it adds all of these together. So 5218 plus 4683 gives me 9901. If I did 4858 plus 4457, that would give me 9315, and so on and so forth for all 82 values. And so we can make a plot with the total number of baptisms per year with the command plot Arbuthnot $year for the first argument, and then the second argument will be what we did. We combine the boys and the girls, number of those, to get the total, and then the type will be an L. Okay, so I'll go ahead and I guess I will just take this. This is my old command. I just kept hitting the up arrow until I got this old command here. And I'm going to change the Y to Arbuthnot $boys plus Arbuthnot $girls. So I got X is the year, Y is boys plus girls, and type will be L. Okay, and we have a similar looking graph, but it is a little bit different. And if we look at the y-axis, the labels of the numbers, we do see indeed it matches up the values that we have, 9901 right there, and so we see the trend there. The command here left off the x and the y equals, and that's because function plot expects the first two to be x and y. So you don't have to explicitly label that the first argument is going to be x and the second argument is y, because it's already expecting exactly that. And so if I type this in, it produces the exact same plot as before. And it says, this time note that we left out the names of the first two arguments. We can do this because the help file shows that the default for plot is that for the first argument to be the x variable and the second argument to be the y variable. And similarly to how we computed the total number, we can compute the proportion of boys to the total. I don't know what, I think this is incorrect here. So this would be the ratio of the number of boys to the number of girls. So 5218 divided by 4683. So here, I don't know why it says proportion of boys. We would do 5218 divided by 4683. We could do this with the entire vector, boys divided by number of girls, and that would be the ratio. Or if we wanted to do the proportion, we would do the number of boys divided by the total number of births. So we would have to add the boys and the girls together. So, and likewise, we can do this with the entire vectors. So we don't have to do it one by one, but with all 82 values at the same time. We would do boys divided by boys plus girls. And so just like your calculator, we have to be conscious of order of operations. So here we want to put boys plus girls in parentheses because we want to add these two together. If we left off the parentheses, the order of operations would have the division, and this would always be 1, and we would just be adding 1 plus the number of girls. But because of the parentheses, we'll do this addition first together, and then divide the number of boys by the total number of children. Okay, so I can do Arbuthnot $boys divided by parentheses Arbuthnot $boys plus Arbuthnot $girls. Okay, and so here is the proportion of all of this, and if I wanted to plot this, I can take all of this and I can plot this against year. So let me just take our last command, and I'm going to just throw in plot. So this, that's not $year, and then the y will be the proportion, and we'll do type equals L. Right, and so here, it looks very spiky, but if we look at the y-axis, we can see it just kind of, the range isn't too big. It goes from 0.505 to 0.535-ish, or something like that. Okay, so it says, now make a plot of the proportion of boys over time, and it says, what do you see? And so actually that's what we just did. And yeah, what do we see? We see it bounces about, but the entire range is almost entirely between 0.505 and 0.535. So boys made up about somewhere between 50.5% to 53.5% of the baptisms in London. Okay. We can also perform comparisons like greater than, less than, and equality. And we can ask if the boys outnumber the girls in each year with the expression Arbuthnot $boys greater than Arbuthnot $girls. Okay, so let me just show you what happens if I say is 8 greater than 6, R will return true, and if I ask is 8 greater than 9, R returns false. And so if I did Arbuthnot $boys greater than Arbuthnot $girls, this will return a vector of 82 true or false values. And what we see is that it is true for all 82 years. So for all 82 years that Dr. John Arbuthnot collected data, there were more baptisms of boys than girls. Okay, and it says this command returns 82 values of either true if that year had more boys than girls, or false if that year did not. Okay, and it says the answer may surprise you, and what we saw was that all 82 were true. The output shows a different kind of data than what we have considered so far. And they are both not data frame. Our values are numeric, okay, the year, the number of boys, and the girls. And here, R is creating a logical vector. That means that the values are either true or false. In general, data analysis will involve different kinds of data, and R allows us to compute these. Okay, so this is kind of the first bit here, and so let me actually just get you started a little bit with this on your own section, because the R markdown stuff could serve to be a tiny bit confusing. So I'm going to put a break in the video here, and then I'll get you started in the next video on this stuff.